Well, how's it going there, pre-calc folk? We're back for video 5 on the unit circle. I know. How many videos can I make about the unit circle? Well, the possibilities are endless, people. I could go on forever, you know that. And I know you're saying to yourself, you're looking at this again and saying, wow, that is such a perfect circle. How did you draw that? Trusty bowl. Right on top there, baby. So, anyway. Enough of that stuff. This is going to be the fifth and final video about the unit circle, but you know, the first 4 videos really just talked about how do I generate it, how do I use these triangles, 30, 60, 90, 45, 49, 5, 90. How do I use those triangles to come up with this, and the radius is 1, and that's why I set the hypotenuse to be 1. That's all in the previous videos. But now the point is, so what? I can write this unit circle. I've got all the degrees on the outside here. I've got the radians marked on the inside here. I have all the coordinates marked. So what? What's the big deal? If we look at this triangle, and I'm going to kind of get in close here. If you look at this triangle, and I'm going to focus on this 30-degree angle right here with you guys, and just talk about SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. So if we talk about that for a second, I said, hey, if I just said use this triangle, and let's talk about 30. So if I said what's the sine of 30 degrees, based on this triangle, you would do opposite divided by hypotenuse from the 30. Well, opposite's 1/2. The hypotenuse is 1. 1/2 over 1 is 1/2. So the sine is 1/2. If I asked you what's the cosine of 30 degrees, that's adjacent over hypotenuse. Square root of 3 over 2 over 1. Square root of 3 over 2 over 1 is just square root of 3 over 2. Dividing by 1 does nothing. Well, I want you to remember these points that are up here. First of all, I don't know if you can see the colors really super well, but everything that's a blue coordinate came from this triangle. Remember, this triangle was originally placed. I have a slightly different circle here than I used when a little smaller. But this went here, and this lined up with this point, which means to get to that point, it's going square root of 3 over 2, 1/2. Remember, the cosine of 30 degrees was square root of 3 over 2 over 1. The sine was opposite 1/2 over 1. This is my x coordinate. This is my y coordinate over here. In other words, all of the x coordinates around this picture are the cosines. The cosine of 30 degrees is square root of 3 over 2. The cosine of 45 degrees is square root of 2 over 2. The cosine of 60 degrees is 1/2. The cosine of 90 is 0. The cosine of 120 is negative 1/2. And so on. All because of this triangle. Every time I do a cosine of 30, it's square root of 3 over 2 over 1. Now, if I reverse that and say, hey, how about 60? 60 is right here now. What's its cosine? Again, adjacent over hypotenuse. Adjacent to the 60 is this guy. Hypotenuse is 1. 1/2 over 1. So that's why when you look at this, it's like, hey, this is the x position. This is the y position. And that's what these coordinates represent. Now, how have I taught myself over the years to remember, like, okay, what's what? It's an alphabetical order. You have your x, y coordinates that are all the way around this circle. They are cosines and sines. X is alphabetical order to y. C is alphabetical order to S. So that's how I remember cosine sine. So I could be able to ask you a multitude of questions off this circle, and you would be able to answer them. Okay? So if I ever said, so if I was in class, I like this part in class because I ask a bunch of questions and I can call on people to answer. So when I tell the class, I'm like, listen for the first words out of my mouth. Am I saying cosine or sine? If I say cosine, x coordinate. If I say sine, y coordinate. And then find out where I'm talking about. And by the way, I don't have to ask degrees all the time. I can say radians if I want. I can say what's the cosine of 30 degrees, x coordinate, square root of 3 over 2. I could have said what's the cosine of pi over 6, square root of 3 over 2. Pi over 6 and 30 degrees are the same angle, just like 100 degrees Celsius and 212 degrees Fahrenheit are the same temperature, the boiling point of water. So you can say this, it's the same thing. So if I, in class, I'd be like, all right, what is the sine? And I'd pause. So people are like, okay, he wants y coordinate. And I'd say, what's the sine of 2 pi over 3? And you kind of look around the circle, 2 pi over 3. He said sine, square root of 3 over 2. Same thing if I would have said, what's the sine of 120 degrees? Okay, so understand that when you get an assignment about this video, there might be a section of the problems that are saying, give the exact sine, cosine, tangent, and so on. Now, let's address tangent a minute. If I bring out my trusty triangle again, you know that tangent is opposite over adjacent. So if you look here, here's 30, opposites here, adjacents here. It's 1/2 over the square root of 3 over 2. Again, please be thinking of this part of the triangle as being x coordinate related, because this was always sitting at the origin. So x coordinate, y coordinate, opposite over adjacent. Folks, that's the y coordinate divided by the x coordinate. So tangent is in a league all by itself. The y coordinate divided by the x coordinate is our tangent group. So there's kind of the information. And of course, tangent questions are always tougher. There are nicer ones, but there are tough ones. So we're going to talk about those because they're tougher. Sine and cosines, just find the x coordinate, find the y coordinate, and tell me. Because it's all based off the opposite over hypotenuse, adjacent over hypotenuse thing here. So, like I said, I can ask you for the cosine of 210 degrees. You're like, 210 cosines x, negative square root of 3 over 2. I could say, what's the sine of 7 pi over 6? Oh, by the way, 7 pi over 6 is the same angle as 210. However, sine is y, so the sine of 7 pi over 6 is 1/2. Now, let's talk about the easiest tangent questions I can ask you, and what are the tough tangent questions I can ask you. Here's a relatively straight, I shouldn't say easy, easier. I could ask you for the tangent of 0 degrees. Folks, every time I say tangent and I'm talking about the unit circle, it's the y coordinate divided by the x coordinate. So if I go to 0 degrees, y divided by x would be 0 divided by 1, which is 0. The tangent of 0 degrees is 0. This is a relatively tricky one when we're in class together first. Tangent of 90 degrees. By the way, I could have just said tangent of pi over 2 if I felt like it, because they're the same angle. Y divided by x. Folks, you know that we can't divide by 0. 1 divided by 0 is an impossibility. We call that undefined. And that's going to be a strange thing that comes up here in a lesson or two down the road. It'll be kind of a week or so down the road from here. When we draw graphs for sine and cosine and tangent, sine and cosine go relatively smoothly. Tangent's always difficult because tangent's got some undefined issues. Okay, now I'm not going to keep doing those, but if I go to 180 and ask you for the tangent, y divided by x, 0 divided by negative 1, back to 0. Down to 270 or 3 pi over 2, if I ask you that tangent, y divided by x is negative 1 divided by 0, back to undefined. Now, some of the nicer ones to ask also, what about the tangent? Let's throw in a radian here. Pi over 4. Now, why is that going to be fairly nice? Look at pi over 4. By the way, pi over 4 is the same as 45 degrees. At pi over 4 or 45 degrees, the two coordinates, x and y, they're the same. Now, I know they're square root of 2 over 2, and they're fractions. Oh, my gosh. But if you ever divide two numbers that are the same, I don't care what they are, the answer is 1, except 0, of course. 0 divided by 0. Can't divide by 0 no matter what. But you'd be doing the square root of 2 over 2 divided by the square root of 2 over 2. That's 1. So if I just kind of talk about the remaining three that are in that same position, tangent of 135 degrees or 3 pi over 4. These are the same coordinates as well, square root of 2 over 2, square root of 2 over 2. However, that one's negative. So when you divide these two, it's going to be negative 1. If you go down here to the third quadrant, 225 degrees or 5 pi over 4, if I ask you for the tangent of those, these are negative divided by negative. That's back to positive 1. And then over here at my fourth quadrant, 7 pi over 4 or 315 degrees, if I ask you for the tangent of either of those, we're back to one of them's negative, one of them's positive, so when dividing them, I'll get negative 1. So there's some of the nice ones. Now, remember, I'm going to erase this over here a little bit. I don't have tons of room here, but the next one's going to take up some space. So you can pause if you need this information. We're going to get rid of this a second, and then we're going to talk about one of the more difficult tangents a second. And then I'm going to mention, I haven't mentioned this in a while, I'm going to mention cosecant, secant, cotangent, and we're going to wrap this video up. But what if I ask you for the tangent of 30 degrees? Because this one's tougher. 30 degrees is right here. I could have said pi over 6. It's square root of 3 over 2, comma 1/2. Tangent is y divided by x. Y divided by x. Now, this one I have to do. Like, I have to pull off this division. Those aren't the same fractions, and no calculator is going to do it for me because the square root of 3 part of it makes that, just the calculator will instantly go to decimals, and I don't want approximations. You guys have learned long ago, years ago, dividing in fractions is supposed to be multiply reciprocal. So, it's not supposed to be 1/2 divided by. It's supposed to be 1/2 times. This reciprocal is 2 over the square root of 3. Now, when you multiply, multiplying is the nicer of the fraction, what's the word I'm looking for here? Operations between like addition and subtraction. Multiplication is much preferred. Multiply across the top. 1 times 2 is 2. 2 times the square root of 3 is exactly that. 2 times the square root of 3. Now, there are two issues here. One's a piece of cake. One's a pain in the butt. The 2 and 2 reduce. Make sure you're careful about that. 2 divided by 2 is 1. So you guys, right now I'm at a position of my tangent is 1 over the square root of 3. We do not leave square roots in the denominator. We will fix that. We will multiply by square root of 3 over the square root of 3. Obviously, square root of 3 over square root of 3 is 1. I am just multiplying by 1, which means I'm not changing any values around here, people. And I chose square root of 3 because that's square root of 3. Now, multiplying straight across once again. 1 times the square root of 3 is square root of 3. Square root of 3 times the square root of 3 is technically square root of 9, which is in turn 3. And finally, there's my tangent of 30 degrees. Now listen, don't confuse this and say, oh my gosh, that is so difficult. It's more just annoying as crap. I mean, just doing all of this. Doing the division, doing the reciprocal, doing the reducing, doing the fixing the square root. It's just this tedious, annoying stuff. So don't translate it as, wow, this is super difficult. It's just tedious and annoying. So anyway, now let's be smart about this. Because we can use this information, I mean, anything that's related to the 30 degrees, which we learned about in the previous videos, 30 degrees transferred across to here. Same two coordinates, same order, it's just this one's negative. So you guys, this tangent will be the same as this, but negative. This one transferred straight down to here. Now that's back to negative divide by negative. So, oops, see I left that negative off there. You guys are supposed to tell me this thing. You're supposed to shout it right through the video camera. Negative divide by negative will be back to positive, same as this. And when you go back across to here, same coordinates, same order. The second one's negative. It'll divide to be negative square root of 3 over 3. So it's not like you have to do this division 50 million times. You did it. We did it. I did it. Now use it to your advantage. Now, I'm going to leave the other part of this to you, meaning, well, what about the tangent of 60? It's the same two numbers, but in a different order, so that it's going to be y divided by x. It's going to be square root of 3 over 2 divided by 1/2. Way easier than this was. This had all kinds of tedious crap to fix. That one will not. That one will be nice, so I'll leave that one to you if you get a question like that in the assignment. Now, the last thing I want to talk about for a second or two, what about the cosecant, secant, cotangent? Now, it's been weeks and weeks and weeks. It's been over 4 weeks since I last saw you guys, which is blowing my mind as I say it out loud. But remember, let me write something down here. Sine, cosine, tangent. Those are the big three. Cosecant, secant, cotangent are known as the reciprocal functions. They're not the opposite functions. They're not the inverse functions. Those are all wrong speaking, wrong terminology. Cosecant, secant, cotangent. There's the connection. Lined up. Reciprocal. So, if I was to ask you, what is the sine? Excuse me. That's not what I wanted to ask you. Got to get my head together here. If I was to ask you for the cosecant of 30 degrees. Now, I'm not going to lie. It helps to have that in front of you. Sine, cosine, and tangent come out easily. You speak them easily. You get used to cosine sine, cosine's x, sine's y. You get used to that. Cosecant, secant, cotangent just never flow, and you're just like, oh, it's the y, it's the x. It's tougher. Cosecant, however, is associated with sine. Sine is associated with y. So you guys, the cosecant of 30 degrees is the reciprocal of what sine would be. It's the reciprocal of the y-coordinate. The y-coordinate's 1/2. Its reciprocal, 2. Technically 2 over 1, but 2. If I was to ask something else, like, what is the secant of 150 degrees? Well, 150 degrees right there. Secant. If I just kind of look at my chart over here, secant goes with cosine, cosine goes with x. It's the reciprocal of x. Secant's the reciprocal of cosine, the reciprocal of the x. So that would be negative 2 over the square root of 3. Here comes some of that tedious crap again. Because I can't have the square root in the bottom, I multiply it by square root 3 over square root 3. Please don't forget the negative. If a fraction's negative, its reciprocal is inherently negative. This becomes negative 2 square root of 3 over square root 3. Square root 3 is square root 9, which is 3. There is the secant of 150 degrees. Now, you can also see that if I was to ask for cosecant or secant of the anything in red, 45, pi over 4, 3 pi over 4, 135, those, obviously if you take the reciprocal, the square root's going to go in the bottom and you're going to have to fix it. One that is somewhat of a pain to some students is the secant of pi over 2. Now, you got to mix in the radians as much as you're like, oh, I hate radians, I hate talking about them. Can't you just say 90 degrees? I could, but I'm not, because you got to be comfortable with both. Pi over 2 is at the 90 degree location, same thing. Secant is associated with cosine. Cosine's associated with x. It's the reciprocal of x. Folks, the reciprocal is 0. Please think of 0 itself as 0 over 1. The reciprocal is 1 over 0, which is undefined. So you guys, that just gives you a lead into like, what's the unit circle about? And for all of you that are going to take calculus eventually, and I know some of you seniors especially, you'd be like, not taking calculus, going on to college next year. Whatever, you're in pre-calculus. My job is to prepare you if you do take calculus, whether you think you are, or know you are, or know you aren't. It doesn't really matter at this point. My job is to prepare you. And Mrs. Wiersma and Mrs. Gagan, our AP Calc teachers, are like, these kids need to know this when they walk in the door. So you need to know your unit circle and therefore know how to do sines, cosines, and tangents, and cosecant, secant, and cotangent, know how to do that and pull off some of these divisions and things. So I've covered all the pain in the butt areas, the undefined areas, the fixing the square root areas. I've covered all the stuff. You now need, you now have all the information on how to do this. So that's something you'll be working on, and I'll have another video coming right after this. It's going to still be about the same section because unit circle is still about section 4.3. There's one more topic in 4.3, and it's a long section. It would have taken us some time to develop that in class, and it's taken us time to develop it here. So thanks for tuning in, people. We'll talk to you soon.